This question is about an amusement park ride. It consists of a rotating platform, like a merry-go-round, and a central pillar, and a hub at the top. And chairs at the ends of ropes or chains that swing around that central hub as it rotates. And they form an angle with the vertical as the hub rotates. And we're told that that angle is equal to 42.6 degrees. And we're asked, what is the speed of each seat? So I can go back to the idea of a force triangle acting on each of those seats. I've got a downwards force of weight, which is equal to mass times the acceleration due to gravity, and a tension force because of the chain. And that tension force can be broken up into two components, which would be the upwards force that counteracts our weight force, and an inwards force that causes the object to travel in a horizontal circle. As a free body diagram, I get tension, centripetal force, and the negative weight force, where this is my theta. And so to relate the two sides would be tan theta is equal to centripetal force over a negative weight force. I think before I do this, separating the variables, I think I'll convert that centripetal force into mass times centripetal acceleration. And then I still have my negative weight force. And the reason I do that is so I can cancel out the masses. It's the same mass. So I'll then separate my variables. Acceleration centripetal is equal to a negative of a gravity acceleration times the tan of theta. I'm going to go back and look at what I'm looking for. It's the velocity, the speed of the chair. So I can't stick with acceleration. I'm going to have to use another relationship. Centripetal acceleration is the speed of the chair squared divided by the radius. I can substitute that in, so it becomes that, and then solve for the velocity or the speed. And it's equal to square root of a negative tan theta. So a negative of a negative 9.8. Let's see, we're going to need the radius. Coming back up to the amusement park ride, the diagram. An amusement ride rotates on a circular platform 9.15 meters in diameter, from which these seats are suspended from the end of a 3.45 meter chain. So I'm going to go from a force triangle to a distance triangle, where the length of this side is 3.45 meters, and I need this side, which gives me the distance there. And then the platform is 9.15 meters in diameter. So I'm going to tack on to the length I get for the radius 1/2 of my diameter. Which would be an additional 4.575 meters. I still have the same angle. So now the relationship between the tangent, or the opposite side, and the hypotenuse would be sine. So sine of my angle is equal to r over the hypotenuse, which is 3.45 meters. So r is equal to 2.3352. So the total radius is equal to my 4.575, this half of my top hub, of 4.575 added on to my chain's additional length on the to the radius of 2.3352. So the total radius is 6.9102 meters. I'm going to bring that down here. And then times the tangent of 42.6. So take the square root. And I get 7.8912 meters per second.